Okay, so 4.5, we are doing exponential log functions, day 2. And our focus today is going to be solving exponential equations that are quadratic type. Okay, so we're going to have a quadratic type, and then we're also going to be solving some real-world problems using logarithms. So we're going to solve exponential equations of a quadratic type. And you can just say solve real world problems using logs. Okay, so for example 1, it says solve the equation. We're going to round to 4 decimal places where necessary. And when you have a quadratic type, you're going to rewrite the expression so that it looks like a quadratic. So to do that, we're going to let a variable be equal using e, okay? So you really do need to state that in there. We're solving, we are going to round to 4 decimal places. Okay, so the first step is you declare that w is going to equal e to the x. Okay, then we're going to rewrite the equation, and then we're going to substitute and solve. So these are our 3 steps. Okay, so step 1, when you say let w equal e to the x, like that's what you'll write in your work. Let w equal e to the x. Okay, if w is e to the x, then this is going to be rewritten as w squared. Okay, because this is like e to the x to the power of 2. So if you had e to the x to the power of 2, you would multiply those together to get e to the power of 2x. And so we can rewrite this as w squared minus, this is just e to the x, so that will be minus w minus 2 equals 0. And then from there, you can just solve for w. So we're going to try to factor. So w and w. Is there anything that multiplies to negative 2 and adds to negative 1? Negative 2 and 1. Okay, so when you rewrite the equation, you are going to solve for w. So w minus 2 equals 0, or w plus 1 equals 0. Okay, so here, w equals 2, or w equals negative 1. Okay, in step 3, you are going to substitute back in e to the x. Okay, so now you're going to plug back in e to the x for w. So that, remember we said that's what they're equal to. So in step 3, instead of w equals 2, we have e to the x equals 2. Instead of w equals negative 1, e to the x equals negative 1. Okay, so we did substitution so we could factor. Okay, and then when you're solving, all we have to do to solve is to do what to both sides? The natural log. Okay, so these would cancel. X is going to be equal to the natural log of 2. So we're going to find that in our calculator. And we're going to round to 4 decimal places. Okay, and then again, remember, you're always looking at that 5th place. And then you're going to see the approximate symbols because we are rounding. Okay, now you would do same thing here where you're taking the natural log of both sides. So when you do the natural log of negative 1, what does your calculator say? Error. Does your guys say domain error? Yes. Okay. So the domain, remember, you can't take the log of negatives or 0. Okay, so when you get the error, this is not going to be a viable answer. Okay, so this is not a valid solution because you can't take the log of a negative. Okay, so that's not something that you need to write down every single time this happens on your homework. It is something you just have to know and be able to explain. Okay, so like once you see that you're taking the natural log of a negative, you can cross it off. Okay, you can say like they're not equal because that's not going to give you a valid answer. Okay, so this is one way to complete these by using your substitution. Okay, this is a quadratic type. Okay, but B is a little bit different. So notice in part A, you have the 2x and then the x. You can't substitute like last time because we don't have like the 2x and then x format. So we have to get rid of the negative exponent using the properties of exponents first. So we're going to multiply each side by e to the x. Okay, and this is why. If you were to multiply e to the x times e to the negative x, that would end up being e to what power? 0. Because when you multiply with the same base, what do you do to those exponents? You add them together. Now, we know that anything to the 0 power is going to be what? Is going to be 1. Right? So, can you guys write out that you're multiplying each side by e to the x? Okay, and then so you multiply both sides, and then you guys are just going to distribute. Now, of course, anything times 0 is going to be 0, okay? But I want you to distribute here. So what's that going to be? Write it. I want you to write it down. So I want you to think about that. When you're multiplying by the same bases, what's going to happen? Oh. Okay, so if you multiply e to the x by e to the x, what's that going to be? So if you add the exponents together, to the 2x, right? Because what's x plus x? 2x. Okay, so don't multiply it. So e to the 2x, okay? And then here we talked about this, right? When you multiply e to the x times e to the negative x, that's going to be e to the 0, and we're going to replace that with a 1. Okay, because anything to the 0 power is going to be 1. Okay, and then we're going to distribute here, so you have minus 3 e to the x, and then this side is going to be 0. Okay, so we distribute to everything. And now we're just going to rearrange it. So now what we can do is we have e to the 2x first, then we'll have negative 3 e to the x, and then what's negative 10 times 1? Negative 10, and now we can do what we did in the first one. Okay, so again, you declare that w will equal e to the x. And I have no idea why they choose w, but that is the indicated variable. E to the x, yeah. You do a declaration for it. For anyone that's your quadratic form. So you're just doing substitution. So you're just letting something represent something else, and then you're rewriting the equation. Yeah. Every one of my homework problems. I would just, I write it a couple times just to make sure you remember it for your okay? It's not like I'm not going to give you points if you don't write it down every time. Yeah, so there's like long mathematical proofs, and often you have to declare statements like this. If we let this equal this, then, thus, therefore, there's a lot of transitions.
The reason why they use because it's the next letter in the alphabet behind the X. You can't use X.
Oh, it's X, not X, Y, Z.
Or
Before it. You should look it up and see. And then what multiplies to -10 but adds to -3? -5, +2. Okay, so then we have our two cases. Okay, and then just do your substitution again. Thank you. Okay, so if W is equal to e to the x, you have e to the x equals 5. You have e to the x equals -2. Okay, so then we're going to do the natural log of both sides. These will cancel, so you guys can calculate the natural log of 5. And then, like I said before, if you see that you're taking the natural log, right, can't take the log of a negative. Okay, then that's not going to give you a valid answer, so we're just going to do the natural log of 5. Okay, and then we guys just round that to the nearest 10,000, so 4 decimals. And then see if you can start C, because I gave you a hint for it. Okay, so I want you to factor out what they have in common. So look at each term and see what they have in common. Okay, so each term has what in common? 4, what else? Good. X to the third, good. Anything else? Okay, good. So you have 4x cubed e to the -2x. That's what we're going to factor out. So when you do that, you're dividing. Okay, so when you're dividing 12 by 4, you'll get 3. X to the 4 divided by x cubed is x. And then when you divide something by itself, it's going to cancel out. Right? And then when you divide 8x cubed e to the -2x by 4x cubed e to the -2x, what do you get? 2. Good. Okay, so what we're going to do here is we're going to treat each term as a different factor. So this is going to be a factor, this is going to be a factor, this is going to be a factor. They're split up like that because you have 1, 2, 3 x's that you have to solve for. Okay, so either 4x cubed equals 0, or e to the -2x equals 0, or 3x plus 2 equals 0. Okay, so we're going to subtract 2. Let's do this one first because it's the simplest. Okay, so one of your possible answers is x is a -2/3. Okay, when we solve this one, we're going to divide by 4. And then if you have x cubed equals 0, we're going to do the cube root of both sides. And we know the cube root of 0 is just 0. And then for the last one, we'll do the natural log. So we'll do the natural log. Okay, and then the natural log and e cancel, you get -2x, but on this side, it's the natural log of 0. Can't do it. Okay, so can't take, natural log is 0. You get an error, so then your final answer would just be x equals 0 or negative 2/3. Okay, so there's several different formats there. All right, so now we are going to use the logs to solve. And our friends are back. We have our good old account formula for compounding interest. So a man invests $5,000 in an account that pays 8.5% interest per year, compounded quarterly. It is. Yeah, it's not usually that high these days. Okay, and then you're going to find the amount in the account after 3 years. Okay, so if it's quarterly, we're going to use, sorry, it's your A of T. Equals P1 plus R over N to the power of NT. Okay, so can you guys find the amount in your account after 3 years? If it's quarterly, how many times a year does that happen? 4. All right, and then make sure that if it's a single digit that you have that 0 there, and then anytime it's money, we're rounding to the nearest hundredth. So we got $6,435, and what was the change? 9 cents. Great. Okay, now B is asking you how long does it take for the investment to double? So if we're trying to figure out how long it takes to double, let's first determine how much is double here. Yep. So we started with $5,000, now it'll be 10,000. So what we're going to do is we're going to solve for T. We want the amount to be $10,000. We want to see how long it's going to take our account to get there. Okay, so we have the 1 plus 0.085 over 4. And then anytime it says how long, that's an indicator that you are trying to find T. Okay, so you can simplify what's inside the parentheses first. If it is a terminating decimal, you can write it down. If you need to use the answer key in your calculator, you can do that as well. Okay, so can you simplify that value inside? Okay, and then once you've done that, think about how you're going to solve for T. What would you do first, though? Yes. Now, when you divide by 5,000, on the other side, you're going to end up with 2. Remember how they said it was going to double? It should always be 2 if they're asking you what happens when it doubles. Okay, and then yeah, we have to use the log anytime the variable is in the exponent. Okay, it is common to use the natural log in these situations. So we're going to take the natural log of both sides. Okay, and then what happens when you do the natural log is you have the natural log of 2 equals 4t times the natural log of 1.02125. What you're doing is you're using the power rule. So when you take the natural log, the exponent is going to come down in front, And then your last step is just going to be to divide. So you want to divide by 4 natural log of 1.02125. Then you'll be left with t. Okay, and we're going to divide by the same thing on this side, okay? Nope, you can do the regular log and you'll get the same answer. Really, you can do any log base you want as long as you do that on both sides. It's just common in the real world problems to use the natural log. Okay, and then when you are dividing, you do want to put your denominator in parentheses. Did any of you try to do it without parentheses? Can you check to see if your calculator gives you the same answer? You forget? Does not?
It does.
It does?
It does.
Okay. I was gonna say, I can do it real quick. Okay, if not, it will go in order and it will divide those first and then multiply that. So you have to make sure you have your parentheses there. And it doesn't say what we're rounding to, so we'll round to the nearest hundredth. Okay, this would be 8.24, and then this was given in years. You could also think about this in terms of like years and month. So this is almost a quarter of a year. So that would be 8 years and how many months? Yeah, quarter of a year and 3 months. Yep.
Couldn't you just graph these equations and set another line?
So you can always use, if you know what your two things are, you can always use your intersection to graph for your homework and for your quiz. It'll say specifically you have to solve the logs, and if you don't, I'm not going to give you points for it. So our goal for this section is to know how to use the logs. Okay? Mm-hmm.
And it doesn't you say you just say 8.5 years, so that would be quarterly.
No, because that doesn't have anything to do with that part, the quarterly. It just happens to be almost a quarter of this year. Yeah, so use your normal rounding rules in terms of if it's 5 or above. Okay, all right, so for example 3, you have a sum of 1,000 invested for 4 years, and the interest rate was compounded semi-annually. If the sum amounted to $1,435.77, what was the interest rate? Okay, so I want you to try to set up your equation based on your information, and then we'll solve it together.
Isn't it every other year?
No. Or semi-annually, like semesters, right? Semesters.
2? So
Companies have semi-annual sales.
I know.
take the first now.
Okay, so I want you guys to set up the equation, and we'll solve it together. All right, let's see if we set it up correctly. So the final amount is the $1,435.77. Okay, and then you have the 1,000, 1 plus R over 2. Okay, and then it'll be 2 times 4, so you can simplify that to 8 right away, or you can do it in your next step. Okay, so if we are going to solve this for the interest rate, again, your first step is to divide by 1,000. So divide by that present value. Okay, and then again, if this is a value with a lot of decimal places, just know that we are not rounding it yet. Okay, you are not going to round until the very end. Okay, so you want the most accurate answer as possible. So do not round until the end, okay? Now, how are you going to get what's inside the parentheses? What do you have to do to both sides? Take the, eighth root. So if it's the 8th power, we're going to do the 8th root. Okay, so this is something where you're going to leave it in your calculator like that. Okay, so this would give you the 1 plus the r squared. Okay, so we're just going to have the 8th root of this value. We're going to do our calculation at the end. And then here, your next step would be to, yes. So don't multiply by 2 first. If you do, you have to distribute the 2 to both. And people usually forget that. Okay, and then I'm fine if you don't write that out every single time because we're going to do that in our calculator. And then your final step is to times 2. So I usually just write like my times 2 here. Okay, and then we're going to find our r value. So to do the 8th root, some of you might have to put the 8 in first, then go to math, then do your root. Okay, so you have 1.43577. Okay, so you want to use that exact value. Then you minus 1, then you multiply by 2. Okay, and then you get 0.0925 ... If you want to find what the interest rate is, you're going to write your answer as a percent. So you're going to take that value and multiply by 100. Okay, and with those, I'll either have you round to the nearest tenth or 100, because this is so nice at 0.25. We'll keep it at 9.25%. Okay, and then if the directions don't say you can round it to whatever you want, just know that you are going to have to round to a decimal place. Okay, so you can practice with the tenth or the nearest hundred. All right, and then example 4, a small lake is stocked with a certain species of fish. The fish population is modeled by the following function, where P is the number of fish in thousands. And then T is measured in years since the lake was stocked. So they give you this equation here. So we have to find the fish population after 3 years. So T is measured in years, so we can just plug in our T value is 3. Okay, and you can do that right in your calculator. So 10 divided by and then again, you're going to want to keep that in your denominator. Okay, so do your calculation and then make sure that your calculation makes sense in terms of the problem. Okay, so it says 7.33. You think that they're gonna stock it with 7 fish? Oh, because I think people would be pretty mad, right? There wouldn't be a lot of fish. Yeah, it says in thousands. So we have to take this value and do what? Multiply by 1,000. And then you can round to just the nearest fishy here. That's a lot of Nemo. Okay, and then it says, after how many years will the fish population reach 5,000 fish? Okay, so how many years is what we're trying to find. They tell you you want the population to reach 5,000. Okay, so let's set up the equation. So if it says how long, we're going to solve for t. Okay, where are we going to put the 5,000? Okay, and then once you put your 5,000 equal there, how are you guys thinking you're going to solve it? Yeah, multiply by the denominator. Now remember here how we got this value multiplied by 1,000? You start with 5,000, you shouldn't plug in 5,000, what should we plug in? So plug in 5. Okay, now if you did it with the 5,000, I was thinking about letting you guys do it and see that it's not going to be reasonable, but I don't want you to write it all out. I want you to keep it organized. So you are plugging in your 5. Okay, and then, yep, your first step is going to be to multiply both sides by the denominator. You can also think of it as cross-multiplying. So you have 5 times 1 plus 4e to the negative 0.8t equals 10 times 1. From here, we would do what to both sides? Divide. Okay, and let's see if you guys can solve it from there. So write it out using algebra. Alright, so then we should subtract 1 from both sides. Then we're going to divide by 4. Then we're going to take the natural log of both sides. So you get negative 0.8t equals the natural log of 1/4. And then your last step is going to be to divide. Okay, so we have the natural log of 1/4 or 0.25 divided by negative 0.8. So you guys get 1.73 years. Right, so that's almost 3/4 of a year, 0.75. So 3/4 of the year would be how many months? Yeah. It's just 3/4 times 12. Okay. All right. I'll put up your homework.